What do you think, everyone? Easy or difficult? Can you analyze that, sir?
So I personally didn't think there was a gap sentence, but I underlined the part where they introduce the algorithm that they developed. And I think personally, all of the information in the abstract are very important, including like it introduces information leakage, and then it also includes the algorithm. So
everyone, let's think about why this abstract is difficult to understand. Can you find the reason? What is no gap sentence? Another reason. They assume.
We already know what is information leakage.
Yeah, exactly. So, is there anyone who knows what is the information leakage in this room? It's not common word. It's not the chair. So it's a really certain term, but they don't explain that at the beginning. That's why it's difficult to understand. Okay.
So that's why I'll explain information leakage.
Yes.
So first, this is our data set, very simple data set. And our goal is that the model will learn about fruit ripeness based on the description of the fruit. So when we perform machine learning, we tend to group into train set, where the train set will help the model learn about the train set. So for example, it'll learn that the red fruit is typically ripe, and green fruit is typically not ripe.
Mm-hmm.
And then with the test set, this is where the model performance is shown. So if we perform based on the learned trend set, it'll show that it'll be correct because it'll see that green fruits are not ripe. So it'll be able to predict that, and we will say it's a robust model. However, with the same model, let's say we have a new input with kiwi, and the description is green. But when we typically think of green kiwi, it's ripe, but the model learned that green is not ripe. So that's why the model prediction will be wrong. And the model is actually not robust. So when we include a new input, we actually reveal that the model is not robust. And this is because the test set is way too similar to the train set. So if you can see, test includes apple and strawberry, and train also includes apple and strawberry, and they're way too similar to evaluate the model performance. And this is called information leakage.
So if the train set is too similar to test set, so information is leaked from the test set to the train set.
Yes.
See. Oh, yeah. Oh, yeah. Yeah. 너무 티내는 거 아니야?
So that is information leakage. And
so everyone is clear what is the information leakage? So typically when we perform the machine learning, we have test set and train set, train set and test set, but test set is too similar to train set, then we call information leakage. So if I give you homework problem, which I cover in the class, then it's an information leakage.
yes, yes.
Okay.
So the very basic idea of DataSAIL is that they will split into train tests like this. And this represents where train and test, they separate strawberries into test and apples into train, so they understand the full data structure of a fruit. And then it won't be able to predict because the model training don't have any information about strawberries or white. And this means that it's more honest. So if we include a new input like kiwi, again, it's not gonna tell us it's a robust model, and then it matches. So what it does is that it avoids similar data points in train and test set, which avoids information leakage. And that is the basic idea of DataSAIL.
So by avoiding the information leakage, the goal is we want to get a similar conclusion between train tests and then validation. So if we call the bottom QE is a validation.
Yes, yes. So very honest model performance. So in order to really test model robustness, we need DataSAIL train test split method. So this is the process of DataSAIL. So let's say, so DataSAIL is usually used in a lot of biomedical applications. So that's why I put like a drug ID data set as an example. And this is just a toy data set, so it's very arbitrary. But let's say we want to, from drug, we want to predict whether the drug is toxic or not toxic. So it's similar to the fruit example. And this is more of like a setup for DataSAIL. What DataSAIL does is it computes a similarity matrix. And I won't go in detail about this, but it basically computes a similarity matrix between each data point. So like with data drug 1, drug 2, and it gives us a matrix like this. And then what they do is they cluster, and users can choose any clustering method for this, but visually we can kind of just cluster them. And
similar correlation.
Yes, yes.
Okay.
So we will have cluster 1, D1, D2, and cluster 2, D3, 4, 5. So that's the basic setup. And then now what we want to do is actually calculate the leakage, data leakage. So first, DataSAIL randomly assigns train and test based on the clusters. So what they did is first randomly put cluster 2 in train and cluster 1 in test. So they kind of randomly do that. And then they provide us a leakage definition that looks like this, and that I will go over. So what this formula does is first they're gonna pair up with all the possible train test combos.
Yeah.
So it's drug 3 and 1 and train and test.
Mm.
So get all the possible combos. And then based on our similarity matrix, we calculate the similarity for all the possible combos like this. And then the K variables represent number of values in each train and test set.
Here, what is the number of
So for example, in train, we have 3 inputs. And then in test, we have 2 inputs. So this will be 3 and this will be 2.
근데 그게 why it can be the function of x and x prime that's I'm a little bit confused.
X and X prime이 여기.
그러니까
So
그렇죠. 거기서 D3, D1을 보면
yes.
so pi D3 makes sense. And similarity D3, D1 is also makes sense. But kappa D3, kappa D1 이게 D3, D1의 dependent function이니까 저렇게 define하는. 아니면 저게 트레인셋이 아니면 D3가 속한 클러스터의 개수예요. 클러스터 개수면 클러스터의
그래서 얘는 시그마텀이 안 들어가는 거니까 그냥 그린 거 같아. 페인트.
아, 바깥으로 있는 건가? 아니네, 저거 시그마에 다 들어가는 걸 텐데.
X가 그러니까.
그러니까, 그래서 좀 약간 그것만 체크해 줄래요, everyone? The paper, kappa definition. 찾아볼래? 알지?
이거죠.
130에서 벗어나. 맞나? 미나야, 저 인포메이션 리키지라는 게 어떤 주어진 걸 트레인이랑 테스트로 쪼개면 그 쪼갠 그룹에 대한 리키지죠.
네, 맞습니다.
아.
트레인이랑 테스트
그렇게 했을 때
그러니까 클러스터를 하는 게 아니라 그냥 트레인이랑 테스트 사이에 리키지가 얼마나 있어요.
그러니까 트레인은 아무렇게나 정하고 테스트도 아무렇게나.
네, 우선. 네.
오케이. Then she might be correct. Let's do that again. Then so Mina, then train test doesn't need to be a cluster, right? Any
Yes, but if the data that is too big, they wanted to group them by similarities first because usually the data set is too big.
but that's how the data save work. But information leakage calculation, we don't need that. This is for any train test set.
Yes.
Yeah, that's why it's confused now. So this definition for any train test set.
Yes, but I was giving him example for this.
Because it gives us the impression that we need to always train test as a cluster one, cluster two. 항상 플러스 원 플러스로 트레인 테스트 하는 건 아니잖아.
그쵸.
이 정의를 하려면 아무거나 해도 되는.
네네네, 맞습니다. 그 전체적인 그거에 맞아.
그렇게 해서 이걸 뭐 좋게 하는 게 좋은 거겠지. 이 값을 미니마이즈 하는 게 클러스터로 하는 게 미니마이즈 한다는 거 아니야?
네네네.
그러니까 저건 이거에 대한 옵티멀 값.
옵티멀 값이 아니고 이거를 먼저 랜덤으로 배정한 다음에 이걸로 테스트를 하는 거예요. 이게 기지가 큰 거죠.
그래? 근데 요새 랜덤이 왜 있어?
랜덤.
어떻게 랜덤 그렇게 하는 거지?
그러니까 모든 그러니까 뭐 클러스터 지금은 2개밖에 없지만 생기면은 뭐 클러스터 1, 2는 트레인에 있고 테스트는 3에 있고 그다음에 뭐 트레인이 클러스터 하나, 테스트는 하나, 둘 막 이렇게 있듯이 모든 상황을 고려해서 하는 거고.
그럼 다시 이거 설명 한번 해볼래? 다시? How do you calculate the leakage step?
Okay. So with the leakage definition, you only want to focus on the data points. It doesn't focus on the clusters. So if we look at the first part, it gets all the data points, the possible train test data points as a combo. So it'll be written like this.
What is pi?
Pi
X
is,
and pi x, pi not equal. What then?
that means that it can't be both train. So one needs to be train and one needs to be test.
What is a pi? Here.
So the paper implies how to separate two terms. So it's a kind of function that sends data to each group.
So pi means that it's either test or train.
Yeah.
So like a trained and zero tested.
Yeah, something like that.
Okay, so we only consider the two things which do not belong to the either to train or test together. Okay, that's the that meaning. And then second term is similarity between their value and then
and then number of data points. So these each values in train set. So not number of clusters, but each data points. So there will be 3 here, and then in test there will be only 2 data points.
So let's think about why it's a information leakage. So similarity makes sense, right? If they are similar between train and test, then leakage should be high. It's correct, right? But what about kappa x prime? Why the number of each train and test is set? Why do we have to multiply them?
The number of set and the test set are say it is minimized. So
It's a maximized actual leakage when they are the same according to this form. So let's say we have a total 100 data. 50-50 is maximized leakage right now. 100-0 no leakage. Yeah, it makes sense. 100-0 there should be no leakage. But 50-50 there could be leakage. Yeah, 50-50, 100-0 it makes sense. So 70-30. Why 50-50 is more leakage than? Does it make sense? 50-50 has a higher chance to be similar between these two groups compared to 70-30. So, 그치? 랜덤하게 섞더라도 50-50으로 섞었을 때 비슷한 놈들이 있을 확률이 70-3? 아, 그냥 단순히 페어의 개수네. It makes sense. 아하. 아, 그러긴 하지. 아, 똑같은 점 없을 때. 아, 그럴 수도 있겠네. 그러니까? So let's think about it. You have 100 people. Let's call that, let's define the information leakage if their birthdays are the same. So we will group to the train and test. Somehow, if there are people whose birthday are the same, then let's say there is information leakage. And let's think about it when the chance of the same birthday people are highest. Like a 199 or 50-50, which has a higher chance to have same birthday, of course. 50-50, because there are 5 times 50 pairs exist. But here we only have a 99 pair. So compared to the 99 pair, 2,500 pairs should have a higher chance to be similar. That's why I think we multiply these two numbers and then some similarity between the actual and then furthermore, what that means is kind of look at the similarity of the shape, kind of like the height, for instance. We think that if a similar height, the birthday chance could be similar. I guess so, because 3 years old baby me, similarity should be very different. So I think that's what we can understand this leakage thing. Okay, so is it okay? Good.
So with this example, we can kind of calculate so the similarities and multiply the values, what professor said. And then 1.2 will be our leakage. But like what professor mentioned, what if we have 0 train data points in train? We will have 0 leakage. So that's why we want to add some constraints. So we still want to make sure that the train test is 80-20 split or 70-30 split, like what users desire. So that's why we kind of want to make sure that the drugs are split into 80-20 ratio. So this is the same assigned train and test cluster. And this is called the entity constraint, where we make sure that each drugs are somehow 80-20 split ratio. So first, we want to focus on the train set. And then the kappa x will be number of values in the train set, so number of the data points is 3. And then we wanna add a small error deviation, some room so that it's not always, because sometimes it's impossible to be like 80%, 20%. So we kind of give some room and include the error deviation. And then we want to multiply the split and the total number of input values. So usually we would kind of like, actually, I'll show you the numbers.
DI가 저게 답니다. 일단 글자는 다 설명해줘야지.
네. 그래서 D is basically like the whole data set, and X is like the input. And then this D first is that T equals R means we want to focus on the train set. So T is like the train test, and R is we want to focus on the train set. And then
저걸 금집하네. 빨리. 인스타트 해줄 수 있는 사람 빨리 찾아서 도움을 주길 바랍니다. 야이에 파이가 되게 이상한데? 버퍼 이렇게 보면 파이가 있는데 신기한 인덱스인데
아니
또 먹을까?
아까 말했던 아까 여기 뭐지?
이게 한 번도 나온 적이
여기에 파이 그대로거든요. 그래서 아까 그 파이가 사실 그 이제 트레인 테스트를 얘기를 하는 거고, 그리고 이제 T랑 R
우선 I가 지금 트레인 테스트 나오는 거 기준이 같고,
네.
R은 거의 펜션하는 라벨이잖아요. 라벨의 비율을 결정하는 거.
그게 뭐야?
그러니까 트레인 테스트인데 예를 들어서 클래시피케이션 문제가 치면 그
클래시피케이션은 세 개라고
네, 저 트레인셋에도 약간 트루랑 폴스랑 약간 비율을 좀 맞춰서
그랬어요.
그런 느낌의 거라고 지금 약간 추측이 되긴 하거든요. 엔티티 타입이라고 적혀있는데 정확하게 뭐라고 적혀있어요?
엔티티 타입이
우리
그
고등학생들도 할 수 있다. 찾아봐, 뭐 빨리. 랩탑 들고 와도 돼. 없어? 없어? 지금. 없는 지 없어, 있지. 없으면 부탁해, 이렇게. 랩탑에 전화 받아. 예. 이거구만. 이거야? 그러니까 애플이 유치하는 정치대회에서 전 세계에서 초등학교 6학년 때 뭘 했지? 중학교 1학년 이유가 맥북이 갖고 싶었어요. 엄마 아빠 컴퓨터 안 사줘야지 편리하게 보내고 아씨 괜히 사. 아니 삼성 받은 맥북 받으려고 경질에 검색해.
그럴 것 같은데.
아니 다 들려준 거다 할인 때문에 했던 거? 너무 있으면 맥북 사.
진짜 여기서 나이가 나이가
일단
백수 할인 비율 쓸수 않을 때
이게 라벨이
아니 라벨이 아니라 정확하게 엔티티 타입이라서
엔티티 처음 들어본다는데 야
여기
나가
단어 선정이 조금 달랐어가지고
한번 찾아봐. 나도 미나가 우리 힘들게 하려고 어려운 거들 만드는. 바이 더 웨이, 그런데 오늘 4시에 한국어로 세미나가 하나 더 있어요.
아예 엔티티 타입인데 그러니까 특정 엔티티 타입에서 계산한다는 것 같은데
그냥 약간 좀 제한 조건들 일단 종류를 그냥 더 운동과
과정이 발생할 것 같아요. 클래시피케이션 포지티브 분석
그거는 C에 그거는 C에 클래스라는 또 타겟 그거 말씀하시는 거 타겟 변수의
네.
0이냐 1이 몇 개인지
그것도 나중에.
그건 C에 네.
나중에 있구나. 그러면
여기 자 우리 고등학생 발언 한번 들어봅시다. 엔티티 뭐냐?
뭘 자체는 그렇게 중요한 거잖아. 그러니까 DI라는 게 그 클러스터들을 줘. D1은 원래서 테스트 셋, D2는 뭐 그 발리데이션 그런
셋이요.
것들이 나오는데
음.
그것들을 비교하는 것 같아요. 그냥 같은 타입에서의 엔티티들을 이제 클러스터별로 분류했을 때 그 비율들이 저런 식으로 나오게.
그러면 저 교집합의 DT는 이걸 R은 별로 안 돼.
그러니까 그건 그냥 타입 all에 해당되는 데이터 포인트라는 뜻이고.
탭이 뭘까?
그냥 예를 들어서 뭐 드롭 타겟 같은 거 생각하면은 여기서 크리에이션 나오는데 그럼 이제 드롭을 나누고 타겟을 나누고 그런 거 같아요.
미나 깨달음이 있었나?
네.
유니세프 했네. 자 해줘.
이거는
영어로 해줘.
so I will explain in detail later,
오케이.
but this is a one-dimensional data set, meaning there's only drug ID. So that's why T equals the drug ID. But if there are more columns like drugs and proteins, it'll be T equals protein. So this is only focusing on the drug, which is, that's why.
오케이. 오.
So
일단 좀 D는 일단 잠깐 잃어버리고 잊어버려도 된다는.
D는 그냥 데이터 셋
중요하잖아.
전체들. So
카파 X부터 다시 가볼까? 그러면 X의 카파 X.
네.
그럼 그 셋에 대한 개수?
네, 맞습니다. So number of data points in train set.
서베이션 2.
And then we add, we multiply a small error deviation.
0.7. 네.
And then we multiply the sample split. So in this case, we want to do an 80-20 split
So
with the train set. So it'll be 0.8 for SI.
SI is the percentage of the.
So
Okay.
it'll be just 0.8
Okay.
because we're focusing on train set.
So this SI is the ratio between clusters.
Yes. Oh, no, not the clusters.
Just
Train
train.
and set.
Train. Okay. And
And then NR is the total number of input values
what's the input
That-
value?
is drug. So the everything. So
Total.
number of drug
Data.
IDs.
We can say that total number of data.
Yes.
Okay.
But R represents that we are only focusing on drug ID. So if there's more dimensions, that's why there's variable there.
그럼 이거 너무 그냥 당연한 거 아니야? 이거 그냥 만약 이거 없으면 그냥 100개면 80% 이상 뭐 그거야?
맞아요. 수가 그냥 너무 복잡하게 돼 있어서.
오늘 오케이.
So,
question.
In the paper that I can be not only 1 and 2 but also 2 and 3 or 4, right? In the paper. Yeah, I can be not only 1 and 2, like for example, like if you only think about a train and test set, then I will be one which, right?
Yes.
However, in the paper, I think the I can be very,
They included validation, but I didn't include validation for simplicity because validation usually is for hyperparameter tuning, but I just wanted to focus on the basic idea. Yes. Okay. So with this formula, we again apply and plug in the values, and you will get 1.96. And what this constraint means that at least 1.98 drug types need to be in train set.
So, Nina, next time, show us the example first. And not,
Okay.
it should be much easier for us to understand the question. Okay.
So, and we know that there are 3 data points in train set. So it's bigger than 1.96. So this satisfies the entity constraint. And then we repeat the same process with the test set. So it's the same thing, but it's just I will be test set. And then we again plug in the values, and this means that at least one drug type needs to be in test set, and this again satisfies. So we just did calculating the information leakage, and then we made sure that the drugs are split into 80 and 20%. And drug DataSAIL includes another constraint, and this is where the class comes in, the target variables. So now we want to focus on the target variables here. So whether the drug is toxic or not toxic. And then with the class constraint, we want to focus on the toxic that are in train and test set. So this part represents that we want to focus on toxic. And everything else is same for that. And then we get number of values that are toxic. And we include the error deviation, and then the sample split. And then this one is number of values that are toxic. The C represents the class, whether it's toxic or not.
So union of the train and test set is not equal to the willingness.
이게 맞을 것 같긴 한데 왜?
아주 조건이 조금 더 커야 된다. 에러 텀이 있어서 하니.
에러 텀 때문에 더 약간 컨스트레인이 약간 더 약해졌습니다.
네.
그러니까 큰 것만 선택하면 됩니다.
그런가?
이퀄리티 아니에요. 네, 그렇죠. 이퀄리티면 토탈이 부족하지.
So
20% 원하는 그 살짝 낮아도 된다.
and then
리퀴드를 맥시마이즈 할 수
if we
있어요.
plug in the values, so
아까랑 똑같은데 뭐가 달라졌지? 다른 넘버로 내가 토박스가 3개.
네, 좋습니다.
독식이 2개 이상 있어.
네. 그러니까 톡식이 그래서 so we need at least 1.92 toxic labels in train set, and then that is satisfied. And then for test set, we need at least 0.48 toxic in test set, and which is also satisfied.
So that means anyway, if we decide to train and test the set ratio, not only the sample size, the label
Yes.
fraction is also following that.
Yes.
Toxic should be 80 and 20% approximately. Okay. Good.
And then now we want to focus on non-toxic. So this is same thing, but only the non-toxic. So if we do this again, we can see that it all satisfies because I made the example, see it satisfies. So as a summary, in order to calculate the data leakage, we have to or calculate the model, the performance of train test split. We have to calculate the leakage and then satisfy constraint 1 and 2. So we just did that for when train is cluster 2 and test is cluster 1. So yeah. So this since train is cluster 2, we just assume that train is D3, D4, D5, and test is D1 and D2. And this is how DataSAIL splits their models.
That's true. See,
However, in the real world, there are more than 2 clusters, especially data sets like this. The data set is very big. So, but for now, let's say we have 4 clusters. So now the DataSAIL is randomly gonna assign train and test sets. So it will give us all the combinations that that clusters can be located in train and test set. And then they perform the algorithm for each train test pairs. So this is what we just did, but it'll perform it for every random assigned train test split. And then from all the pairs,
아이랑 탄데. 그냥 다 해보겠다는.
맞아요.
근데
그쵸.
사실 그냥 다 해보자는 건데,
키즈만 계산하는
그러니까 다 해보고 리키지 계산하고 컨셉 1, 2 만족하는지를 보는 건데,
맞아요.
그걸 다 하려니까 너무 많으니까 그래도 그냥 클러스터링 정도
맞아요.
해서 하겠다 이건가?
맞아요.
이게 네이처펌이라고? 야, 씨, 네. 더욱이다. 일단 뭐가 더 있겠지. 다 있을
좀 많이
거야.
없는 거. What we do is we select the lowest leakage and the split that satisfies the 2 constraints. So that's how it's collected.
Oh, can you go back? Sorry. So, among the satisfied, we want to select the minimum.
Yes.
But that means the 80 to 20% split ratio is maintained, but the train test set similarity is in.
Yes. So they showed us this graph where this is a random train test split, and then this is DataSAIL. So you can see that it's more like clustered.
김현 박사님, 이거 어떤 느낌? 왼쪽은 그냥 진짜 랜덤하게 섞여 있는데,
네.
오른쪽은 저렇게 돼 있는데, 오른쪽이 진짜
보통 샘플링 할 때 최대로 무고로
그러니까 왼쪽을 원래 선호하잖아.
선호하는 그 선수. 근데 이건 좀 특이해. 그러니까 저 리케이지 완전
그러니까 so I think my feeling is this easy problem, challenging problem.
Yes.
어려운 문제 누가 더 잘 푸냐.
맞아요.
I see. 그러니까 네.
음.
일반고 문제, 영재고 문제가 되겠네. 그러니까 이것도 하고 이것도 해보는데 이거는 좀 할 만한 거고 그 다음 됐을 때 이것도 되면 진짜 대박인 거고
그치.
이런 느낌인 거구나.
그러니까 이걸 하면 약간 새로운 데이터가 와도 로버스트하다 약간 이런 느낌.
I see. So in this, if they tested this, the new data should belong to some over here. Then it should be fine. But come here, we are not sure. But in this case, if they pass it, that means this model is quite universal. So that if new problem comes, it will be working.
in the training perspective, we put the input of a different domain of the model. The model should fail.
Yeah, but what if there is some governing law,
Governing.
like the F equal MA?
And
So if we show the some coupled trajectory, but if our model, if there is universal law exists, and then if your AI learn that universal law from this coupled trajectory, then new trajectory should work. Like if there is no universal law or governing law, AI should fail for this problem. 아, 그래서 이걸 하는 거구나.
So maybe this could be the good criteria to compare some mechanistic-based model and data-driven model.
Exactly. Yes, yes. 아,
So
재밌다.
they showed another graph. So this part is, so they used 5 different models, but applied different train test splits. And you can see that ROC AUC for DataSAIL was the lowest because it's the most challenging.
Typical
Split,
problem.
yeah.
Yes, yes.
And then if you look at the split leakage, DataSAIL has the lowest as well. So this kind of shows that.
It's a typical problem.
And
So here, different color means different type of the string heads.
so orange is just random.
So it's easiest.
Yes, yes.
아, 그러네. 초, 중, 고, 대학 문제네. 얘네가. But so far in our group, we have only used the random.
Right, so we usually test several random splits.
Yeah.
And we report some distribution.
Yeah. That means we only try to solve the easiest one. 하하. 나도 같은데? Okay.
Another part of DataSAIL is that it can split 2-dimensional interactive datasets.
Is that all? So after this, they never try to when the new data comes.
저도 좀 그거 의아하긴 했는데.
그러니까 이걸 하는 이유가 뉴 데이터 왔을
그쵸,
때될
그쵸.
거라는 거나 뉴를 줬어야지.
그리고 사방
이럴 거야? 그러니까 oh, I see. Anyway, if this paper become really valuable, they have to show it that. So yeah, we have a 2 for the same random forest model. We can use either random for this challenging problem. Okay, this looks better, but when the new problem, completely new problem comes, hopefully this type model show the better performance than this random trained one. Then, 근데 이걸 안 진짜 안 했다고?
네. 이거 어려워요.
But at least they could try cross-validation by using this method.
네.
And
I
then
was-
they train the model, then they could test another test. If that works, then it really, yeah,
오, 이거 많이 물어봤다고.
they didn't.
심한데, 그런가? 아, 지금 약간 엄청나게 기대는 갔다가 영화가 좀 재미없어졌는데? 이러면 좀 그렇지 않나?
맞아요. 저도 사실 그거 보고 좀
어.
이게 계속 찾았어요. 그 부분이 있나 없나. 근데 안 보였어가지고.
아, 근데 what that means is if we can show it, you choose this paper. Why don't you show that it could be the good one
Yes.
for your survey data? Cancer patient could be the new type of data. For your cancer, your normal per survey data, you train in this 2 different ways. When the cancer patient comes, which one work better? Something like that. Does it make sense?
Yes, yes. So another part of DataSAIL is that it can split into 2-dimensional interacting datasets, and that is what the R represented earlier. So we again have like a drug ID dataset, and then let's say we have a new dataset, protein ID. And the reason why it's called interacting dataset is it kind of makes a pair between each data points of drug and protein. So it'll make a total of 12 interactions. And these are basically the data points. I'll show you how we could visualize it. So it basically shows the interaction between the drug and protein. And these values inside are the target variables. So D1, P1 means they bind, and D1, P2 means they don't bind. So there are two different types of inputs that make up interaction. So we repeat the same thing. First, we get the similarity matrix, but we do it separately with drug and protein. And then we cluster again. And then they would assign train test based on the clusters. So they would put all the possible train test splits, and then they get the leakage again and make sure the constraints are correct. So this is just a repetition. And then let's say we select this train test split. And then if we visualize, we say that the drug cluster 1 is train, drug cluster 2 is test, protein cluster 1 is train, and protein cluster 2 is test. And if we lay out all the interactions, it'll look something like this, where D1 and P1 are both train, D1, P2 are both train, like that. And what DataSAIL does, it only selects drug protein combinations that overlap train test split. So they simply just omit interactions that are not the same. So they have to make sure they're both test and train. And so they finalize the train set with these data points. So that's why they mentioned one of the limitations of two-dimensional data set split is that there's some loss of information because they're omitting some of the parts. But yes, so if we look at the, oh, sorry, there's a typo, but this is two-dimensional performance. So if we look at it again, you can see some, so this is for drugs and this is for protein. So we can see that there's some clusters for test. And then again, they calculated the RMSE, the error, and we can see that this DataSAIL error is the highest, and then the leakage is the lowest.
The case is lowest. So, here in this case now RMSE.
Yes.
Error is largest.
Yes.
But it's a difficult problem.
So this is the conclusion, and they have a GitHub that you can use. And I think these three are the main things that covers the algorithm of DataSAIL.
Any question?